everyone. Good afternoon. My name is Yashraj and I'm the head of product at About Energy. So today I'll talk to you about how we can leverage basically battery digital tools to increase the efficiency with which batteries are being introduced to the aerospace sector. So who are we? So we are About Energy. We are a battery and data modeling company. We are effectively a spin out from Imperial College London, and we supply battery data and models. So that's as basic as it gets. But what does it really mean for everybody present here today, and in general for connected places sort of going forward into the future? So everybody's talking about batteries and everybody wants to build batteries, especially with recent announcements in the aerospace sector. But the key thing is that making batteries and particularly testing batteries to make sure they are safe, they are long lasting, cheap and everything is very, very expensive itself and is a very slow process. So that ultimately delays the development process or the product introduction process by 3 to 5 years. So the big thing there is that ultimately you spend a lot of money with low assurance on what it will deliver. So you've recently read a lot of news about how big companies even like Tesla and others have struggled to sort of meet the order demands. That's largely driven by manufacturing issues as well as issues in making sure that they're able to scale up new and new technology going forward. So what does this mean for aerospace? So the aerospace industry is going to be like very big, particularly in the eVTOL sector by 2030. There was a nice talk in the other room around how eVTOL sort of vertiports and the network around it is going to impact our mode of transportation going forward. But the main problem is that if you compare it to the automotive sector, which is EVs like Teslas, Jaguars, Nissan, Leafs and so on, is that the blue bit is where the automotive sector has placed in terms of what it needs from its batteries. And the pink bit or the red bit is where the eVTOL battery requirements are placed, in terms of safety, power, lifetime and so on. So which means in a nutshell that these battery technologies are dead on arrival, and that's particularly driven by how much the certification challenges are, that you need to make a safe landing and so on. So which means that any sort of technological challenges are directly impacting the business case. So we can't afford with respect to the automotive sector how much time we can spend in the aerospace sector developing and researching batteries. So there's a big sort of catch-up game here involved. So what we do is that rather than sort of trying to solve problems at different stages of the development cycle, we are trying to connect all the sort of parts of the value chain, particularly around battery modeling and battery data sets, so that everybody involved in this process can benefit from it directly at the beginning of a product development process. So how we do that is through through our models, obviously electrical, electrochemical, thermal and degradation, but also through web tools. So let's say you want to select a battery technology for your application. You just have to click a button, set your requirements, and you would be able to do it sort of almost instantly. So that's sort of the idea around us being a one-stop shop for battery innovation across the entire value chain of the industry. So moving on to what we are doing during this trial. So I'll go through a very wordy statement, but it essentially means that we are connecting key technical drivers to key business drivers. And we are doing that by sort of working with a leading advanced aerial mobility company to demonstrate the value proposition from both a product as well as a technical perspective. So simple thing like if the battery heats up quickly, then you wouldn't be able to charge fast enough. If you're not able to charge fast enough, the number of flights per day will reduce. If the number of flights per day reduces, then the cost per ticket goes up, and it's a vicious cycle which will be very hard to break out of. So through this, we are going to be using all of this, like our state-of-the-art electrical models, thermal models, electrochemical models, and degradation stuff to sort of understand a cell technology from every aspect, and in turn convert it into battery life as a function of weight. For example, how heavy the battery can be so that it will last a full year, for example. If it doesn't last a full year, how many aftermarket replacements will be required? It could be one every month, it could be one every 6 months, and ultimately how much that affects the company's business case and commercial traction. Similarly, if I want to charge a battery in 10 minutes versus if I charge a battery in 30 minutes, how many cycles and how many missions I can get out of it every day. So that's sort of how we are looking at it. The left side is the technical space or the technical piece, and the right-hand side is the product piece. So how they merge together is where we really sort of come in. And we are doing that through sort of our Volt platform, so which essentially is a web-based service through which you can go in, look at every solution, every battery technology which is out there, and build out models and drop them into your own system design tools. So it could be that you are a aircraft developer who has no idea about batteries. You could come in here and say, okay, I want a battery to last for 500 cycles. I want a battery to charge in 10 minutes. So we would work with you to try and deliver that solution, or at least be technologically sound doing that. So yeah, in a nutshell, yeah, we are providing digital tools to create pathways so that people, our customers, can develop their own IP. So that's where the real victory for us is. And yeah, so that's it from my side.
So brilliant, thanks very much. Yash, you want to join me down here and I'm going to ask you a few questions. So for anyone, I didn't explain this very well, so for anyone watching, so a part of the Future Air Mobility program, which both Sylvia and Yashraj have mentioned, is that they get to do trials of industry. So they work with industry partners, whether it's a local authority or private business, to kind of trial out their technology or enhance that value proposition for the sector. And the third thing is, I know in About Energy you've done stuff within the automotive sector, you're now doing stuff within aviation. As having spoken to Sylvie, we can see that it's moving and accelerating at such a fast pace. What's been the biggest differences for About Energy in dealing with automotive versus aviation?
I think it's this exponential curve where we are at the starting point of that curve, whereas the automotive sector had 20 years to develop solutions and do a lot of R&D, where the aerospace sector has very ambitious entry into service targets in the next 5 years. And we think that we are very well placed to fill that technology and skills gap which exists in the market. Yeah. And on the other hand, if a car stops on a highway, you can jump out of it or walk out of it. Yeah. But you can't afford to have a battery stop flying midair. So so that's where we sort of come in. That if you have very accurate models, you will be able to predict if the aircraft will be able to complete its mission successfully. So that's where we sort of come in.
And within saying that, would you look in terms of your main target market be the likes of airplane or plane manufacturers? Would you be looking more at vertiport operators? Who would be your main kind of target customer for that there? And what are some of their pain points at the moment? I know you've alluded to some in the presentation, but it'd be good to get a bit more sense of that.
Yeah, absolutely. I think we look at us offering our solutions to both the eVTOL companies as well as vertiport players. That's because you need batteries for both, first of all, and there's a big overlap between eVTOL companies and motorsport applications. So high power, high charge rate, and so on. Whereas on the other hand, vertiport applications, vertiports will require stationary batteries, which is very common with stationary batteries being used commercially globally. So I think there's a lot of overlap, and we can sort of leverage our own technology to deliver to both aspects.
Brilliant. And in terms of like what your trial at the moment, I know it's still very early stages within that, but what are you hoping at the end of the trial the kind of biggest impact will be in terms of what you learn that can then apply sector-wide? Because you're going from, as you said, the automotive into the aviation. What are you kind of hoping the outputs of this trial will be?
I think the big one is building trust in models. Yeah. I think at a very high level, that everybody's, I'm an experimentalist, so testing out everything is very cool and it builds trust, but we want to build trust through our models so that aerospace, which is very certification heavy, they can trust to use our models at least in their R&D stages. Yep. That would be the first place. So that's where we are working with our partners to convince them and convince the wider industry that, okay, you shouldn't look at models as something very high tech or chemistry based, but look at it how it's solving your engineering challenge or product challenge. So that's how we sort of want to approach it.
And as you mentioned there...
Sorry, we're going to have to cut that short.
That's no problem, that's great. Listen, thanks very much, Yashraj. And if people want to get in touch with you, what's the best way to do so?
Yeah, sorry, I missed my email address there. So it's yashraj@aboutenergy.co.uk.
Okay, perfect. Thanks very much.
Brilliant. Thank you to all three of you. That was excellent, really exciting.